So today we're back to Unit 6. We're going to be Day 2 and Day 3 actually go together, so we're just going to be splitting it up. So before we start the Day 2 notes, there's a warm-up that I want to go over, which will cover what we did on Day 1. All this stuff kind of ties in. Okay, so for the first one, we want to simplify, it says, to a single trig function. So because it says a single trig function, that means your answer can only be one trig function when we finish. So I noticed that these they all are in terms of sign. So that's good, that's setting it up for factoring. So if we want to factor, we would want this to be in descending order. So we would want to put sine to the fourth x first, and then minus 2 sine squared x, and then plus 1. So put it in the correct descending order. So after that, think about factoring. If you were going to factor in, you can do this the long way or the short way since there's not really a number out front. So technically there's a 1. So 1 times 1. So you're trying to find two numbers that multiply to give you 1 and add to give you negative 2. So we could use negative 1 and negative 1. Okay, I'm just going to go and do it the long way. So if we brought down the first term, instead of the middle term, we're going to have minus 1 sine squared x. You got to make sure you put the square because it's squared here. And then we have another minus 1 sine squared x. And then we bring down our last term. And then we're going to do grouping. So GCF out of the first two is sine squared x. If you take out sine squared x, you'll have sine squared x minus 1. And then grouping the last two, GCF there. We just want to make that negative 1. So we take out negative 1, that'll give us sine squared x minus 1. So the insides are the same. So one factor is sine squared x minus 1. And then from the outside part, the other factor is also sine squared x minus 1. Okay, so if you remember from Day 1, we had this Pythagorean identities that you have to know. So if you remember, there's one that has sine squared, cosine squared, and 1 in it. So over here to the side, just a reminder, cosine squared x plus sine squared x is equal to 1. Okay, so I want to rearrange to make it look like this. So in order to do that, I would have to subtract this 1 over. So cosine squared x plus sine squared x minus 1 equals 0. Well, I only want sine squared x minus 1 here, so I'm going to move over the cosine x and make it negative. So sine x squared minus 1 is negative cosine squared x. So this right here is negative cosine squared x, and this right here is negative cosine squared x, because those are the same thing. So then if I multiply those two things together, the negative times the negative just gives me a positive. And then this will end up being cosine squared times cosine squared, which will be cosine to the fourth x. So now we have gotten it to one single trig function. It can be to any power. So this simplifies to cosine to the fourth of x. Alright, then if we take a look at number 2. So for number 2, they're asking you to simplify again to a single trig function. So when we finish, we should only have one trig function, but it can be to a power. Okay, so this one, first remember, you want everything to be in terms of sine and cosine. So with that being said, a lot of times, now you don't do this every time, but a lot of times if you have a tangent, you're going to change it. If you remember, tangent is sine over cosine. So because it's tangent squared, that means that tangent squared is sine squared over cosine squared. Okay, so I'm going to rewrite the top part as sine squared x over cosine squared x. Alright, over. Now, on the bottom we have 1 minus cosine squared x. It is in terms of cosine, but because of this 1, let's think about our Pythagorean identities. We just said cosine squared x plus sine squared x is equal to 1. I want to rewrite this Pythagorean identity so it looks like this. So we want it to say 1 minus cosine squared x. So I can just move this cosine squared x over here. So that means that 1 minus cosine squared x is equal to sine squared x. Okay, because I have a fraction divided by, and I can make this a fraction, we're going to do same change flip. So I'm going to keep the first fraction the same, change it to multiplication, and then I'm going to flip the second fraction. So because sine squared is in the numerator and the denominator, we can cancel those out. So we're left with 1 in the numerator over cosine squared x. Well, remember, 1 over cosine is the same thing as secant x. Those reciprocal trig functions. So, just because it has a squared, all that means is this turns into secant squared x. So we've gotten this to a single trig function, which is what they asked us for. So the answer for number 2 is secant squared x. Alright, and then if we take a look at number 3, this time the directions say factor. So they're not wanting a single trig function, they just want you to factor. So guys, in order to factor, you have to have all the same trig functions. Okay, this one is fine, but you can't have tangent and secant. Because we know those are Pythagorean identities, you're going to always want to change the one that's squared in terms of the other one. Okay, so if you remember, we know that tangent squared x plus 1 is equal to secant squared x. That's one of your Pythagorean identities, okay, that you would have to memorize. Remember that. So I want to just solve it for tangent squared x. So I'm going to move this 1 over. So tangent squared x is secant squared x minus 1. So I'm going to replace this tangent squared x with secant squared x minus 1. And then I still have everything else here. Okay, so I'm going to distribute out that 4. So I have 4 secant squared x minus 4 minus secant x plus 1. So everything's in terms of secant, which is good. So we just need everything in order, and we need to combine like terms. So 4 secant squared x is going to be out front, minus secant x, and then I'm going to combine the negative 4 and the 1 and get negative 3. So now we are set up to factor. So if you were given this problem to start out with, you wouldn't have had to do all the other stuff, but the reason we have to do the steps is because you have to have the same type of trig functions before you can factor. Alright, so from here, because there's a number out front, we're going to have to do the long factoring. So 4 times the negative 3 is negative 12. Two numbers multiply to negative 12 and add to negative 1. So we're going to have negative 4 and 3. So I'm going to bring down the first term. For my middle terms, I'm going to have minus 4 secant x and plus 3 secant x. And then I'm going to bring down my last term. Okay, so we have to do grouping. So GCF from the first two terms is 4 secant x. That'll leave us with secant x minus 1. Group the last two terms. GCF there is 3. So that'll leave us also with secant x minus 1. Inside factors are the same. So one factor is secant x minus 1. The other factor is the outside part, 4 secant x plus 3. Okay, these do not simplify at all, which is why they just asked you to factor and not do a single trig function. So those would be my two factors. And then the last question for the warm-up, we actually want to solve. So guys, if it says solve a trig function, then when you finish, you should have to go to your unit circle to get your final answer. Okay, and we are solving on the unit circle. We're going to use the whole unit circle, except for we're not going to include 2 pi if that happens to be the answer. Okay, so when you're solving, a lot of times, so we're going to be solving again on the last day of this unit. They're going to get a little more complicated as they go. But a lot of times for solving, you're going to be factoring. So remember, in order to factor, you have to have the same trig function. So if you see here, we have the same trig function, so we're good on that. So you would just want to look for a GCF here because there's only 2 terms. So the GCF here would just be tangent. So I'm going to take out tangent x. If I take out tangent x, it's going to leave me with tangent x plus 1 equals 0. So, that's good. I'm ready to split this down the middle. I have tangent x equals 0. And this one is tangent x plus 1 equals 0. Alright, so I'm going to pull up the unit circle. Okay, so for tangent x equals 0, remember tangent is y over x. So we're trying to find somewhere on the unit circle when you divide y divided by x that's equal to 0. So look at on your unit circle, y divided by x. If you look at 0 here, 0 divided by 1 would be 0. So 0 is going to be one answer. Remember, if you're using the whole unit circle, most of the time you have two answers. So if we go up here, if we do 1 divided by 0, that doesn't work. That's undefined. But 0 divided by negative 1, that will give me 0. So pi is another answer. And then negative 1 divided by 0 doesn't work. If you come back around, 2 pi does work, but remember it was a parentheses here, so we're not including 2 pi. Alright, then so for tangent x plus 1, I'm going to move that 1 over. So we're really looking for tangent x equals negative 1. So once again, tangent is y over x. So we're looking for when we divide the y divided by x, we get negative 1. So the only time you'll get 1 or negative 1 for tangent is whenever you have the square root of 2 over 2. So like pi over 4 would be positive, so that's not going to work. 3 pi over 4 would be negative. So one answer is 3 pi over 4. And then at 5 pi over 4, that would be positive. But at 7 pi over 4, that would give you a negative answer. So there are 4 solutions to this problem. 0, pi, 3 pi over 4, and 7 pi over 4.